Okay, so the first one, in Cartesian, we are given the cos of x squared plus y squared dy dx. 0 to 2 square root of 4 minus x squared. So now, how can we convert that? And we are not given the region, but we can get the region from the limit given. Okay, so now firstly we want to convert the function first. So the function in xy, it is cos of x squared plus y squared. So we have cos of, so in r and theta, so we have cos of r squared. And we know that our dA is r, dr d theta. Okay, so how about the region? So we should have the region first. So in order to get the region, from the limit given, we have x from 0 to, and we have y from 0 to square root of 4 minus x squared. So then you have to apply the same way that we have already an example in Cartesian before this. How can you get the region from the limit given? So you have to rewrite that interval into the equation. So you have y equal to square root of 4 minus x squared. Okay, so now based on this, we know that the y value is always positive, right? This is from the original expression given. But in order for us to determine the function in general form, you have to rearrange. So you will get y squared plus x squared equal to 4. So we know that it is a circle centered at the origin. Radius is 2. So from the equation that we have, okay, so on y-axis plane, so that is the graph that we have, but we know that the y is always positive, so meaning that we only have the graph only on the positive part of y. Okay, and then to know what is the area that we need to shade, because we have to determine the region, right? Then you have to look at from the limit again. Okay, so you look at the order. The order here, x is constant. So when x is constant, you have to draw a line where we'll guide you to determine the limit, right? So we have a vertical line because x constant. Okay, and then you look at your limit of x. So x only 0 to 2. So x only positive 0 to 2. So meaning that this should be not our part of the region. So you have to erase that. So this is not part of the region. Okay, the region that we have only lying on the first quadrant. But then now we have to double check what is the region that we need to shade. So now you have vertical line. So this vertical line is telling you that the line you have is between 0 and 2, and your lower bound of y is 0, which is this one. Sorry, which is this one, and your upper bound is the part of the circle. Okay, that one. So meaning that your region that you need to shade is this one. So that is your region. Your region is just part of the circle on the first quadrant. Okay, so now we know that we already got the r, the region. So that is your r. So now we have to convert everything into polar. Okay, so now we know that your region is part of the circle. So that's why the question here asking for solving using polar coordinate, because your region is part of the circle. Okay, so now what is the equation? Because you have to find out the equation of the circle in polar, because you want to we want to use that to be the interval of the r and theta, right? Okay, so in that case, we know that your r, that equation is coming from this equation in Cartesian. So we know that one is, if we convert into polar, so we have r squared equal to 4, right? And because we get r equal to 2. So remember, r radius is always positive. So here r is 2 is a circle centered at the origin with radius 2, as we can see here. Okay, so now we know that to solve this in polar, then we can rewrite this into polar equation. So you have cos r square r, okay, r dr d theta. Okay, so what is your limit? Okay, limit of theta. So look at your r. So you can see that your region is in first quadrant. So first quadrant meaning that one we will the smallest theta should be 0, right? Because it is the part of the region is also lying on the x-axis positive. So the theta should be 0. Okay, and then also the highest theta that we should consider here. So now we are talking about the angle. So that is the angle. So the highest theta should be 90 degree, because 90 degree is part of the y-axis positive. So then we should put the 90 degree. Instead of we use the 90 degree, we have the pi over 2. Okay, pi over 2. How about the limit of r? Okay, how can we determine the limit of r? So you have to provide a line starting at the origin. You can provide many lines, so you can see that all the smallest are starting at the origin, right? So 0, and the highest r is part of the line of the circle, which is 2. So that is your limit. So theta 0 to pi over 2 and r 0 to 2. As you can see here, all the limits are constant. Why? Because we have the region where it is part of the circle centered at the origin. Okay, so that's why our limits r and theta are constant. So now it's time for us to determine, to evaluate. So in order to integrate, first integrate respect to r, cos of r squared multiplied by r. So we have, I just put r cos of r squared dr d theta. So you can see the single r outside cos, and there is r squared inside. So meaning that we can use a direct substitution where we let u equal to r squared. So du over dr is 2r, and then dr will give you du over 2r. So your r here can be cancelled out, then your expression becomes simpler. Okay. So r cos u du over 2r d theta. So r here can be cancelled out, so you have only cos u du d theta. So now your expression becomes simpler, but in terms of u, then we can directly integrate. Okay, so your integrate cos will give you sin u, but remember your limit given is only belongs to r, and you replace back the u is r squared, and then you substitute the r is 2, so you have sin 4 minus sin 0, it is 0. So you have sin 4 is just a number. We can take it out for a while, and we have to evaluate later on. So you have sin 4 over 2, and integrate 1 d theta. So integrate 1 d theta will give you theta, and substitute the limit of theta 0 to pi over 2. And when you simplify, we have this, and then you have to evaluate sine 4. Don't forget sine 4. 4 here is a number which is radian. So please set your calculator in radian mode. So pi negative sine 4 using radian 0.7568 in 4 decimal places, 7568. Okay, divided by 4. So you will get negative 0.5944 in 4 decimal places. Okay. How about the second question? Okay, so by applying the same procedure, which means that you have to convert everything into r and theta. So the second one, the integrand given is y squared over x squared plus y squared x dy. So now the function we have to convert. Okay, but then firstly we just copy the limit y 0 to 1 and x is 0 to 1. Okay, so firstly we want to convert the integrand, where the integrand given is y squared over x squared plus y squared. So the function in r theta, so we have r squared sine squared theta over r squared. So we only have sine squared theta. Okay, so now your region. So we want to know the region looks like. Then you have to take the interval that we have, where y is constant 0 to 1 and x is from 0 to y. Okay, so you have y equal to 1, y equal to 0, x equal to 0, and x equal to 1. So from the equation, we have y equal to x. So now we want to sketch. So we have the line of y equal to x. So this is y equal to x, or x equal to y, and then we have y, and this is x, and we have y0. Y0 is this one, x0 is this one, and we have y equal to 1. So this is okay. So now we check. So this is y equal to 1 and y equal to 0, and we have y equal to x, and we have x equal to 0. Okay, so now obviously the region is over here, but we want to double check whether is that correct. The region is over here. So how can we double check? You have to look at your order. Given is the x dy, y is constant. So when y is constant, so your line should be horizontal, right? And you can see that the y is lying 0 to 1, yes, and x is from 0 to y. So you can see that that is x equal to 0, and this is x equal to y. So what we can say that your region is here. So that is your R. Okay. Okay, even though your region is not a circular region, but still the question, but because of the question asking for converting into or changing into polar, then you have to follow. So now you have to find out the equation here, or the equation in r and theta, the equation of the the region that we have. Okay, so we can see that the equation that we have is y equal to x. So as I show you before this, the y equal to x will then convert into theta equal to pi over 4. I have shown you before. We have theta equal to 45 degree. Okay, so now we know that you have theta pi over 4. Okay, and then what else that we need then? Okay, so now let's say, okay, firstly we want to find out, we just substitute first the function that we have, so the integrand that we have. So if the integral then converted into polar, we have sine square theta, and then r dr d theta, right? So now we want to obtain the limit of theta, and we want to obtain the limit of r. Okay, so how can you determine the limit of theta? So now this is your region. So what is theta? Theta is the angle. So is that possible for me? So now just look at here, your region here. So what is the theta? The theta is the angle. So then from there you can see that your angle that you have here is, which part of your region is here, right? So this is not 0. What is the angle for what is the angle that you can have here? It is part of the straight line that you have, which is y equal to x. So what is the value of theta for this line? So we know that that one is theta equal to pi over 4. So your smallest angle that we have here is 45 degree or pi over 4. And then from the region again, so you can see that the highest theta belongs to this line. So this line is what, as is positive, is theta equal to pi over 2. So now you can say that your highest angle is pi over 2. Okay, so now about the r. How can we determine the r? So again, in polar, how can you determine the limit of r? So you have to draw a line. Okay, you can provide many lines. So you can see that the smallest r is 0, because we know that the region here, part of the region is also 0, 0. So we know that the smallest r that we can have is 0. And the highest r, so the highest r, which is this one, right? Okay, so you can see that the highest, the maximum, sorry, the terminal point. So the terminal point for any lines that you provide. So all the points here belongs to the straight line of y equal to 1. But since the y equal to 1 is the equation in polar, so then you have to convert the equation into since y is in Cartesian, then you have to convert into polar. So how can we convert? So you have to use the formula. Y in terms of polar is r sine theta is equal to 1, because 1 is just a number, it is fixed. So now you want to have r, not theta, right? So r equal to 1 over sine theta. So now your r is 1 over sine theta. Okay, so now we put the limit. So theta just now is from pi over 4 to pi over 2, and your r is 0 to 1 over sine theta, right? 1 over sine theta. Okay, so now we managed to convert everything into polar form. Then we can start to integrate. So to integrate, sorry, again, I made typo here. Right, this is not. Or is that correct? Yeah, that's correct, theta. That is theta. Okay, so now you have to integrate first with respect to r. So your r is just here. So sine squared theta is just a constant. So we don't disturb the sine squared theta because it's constant. So you have r squared over 2. And replace the r 0 to 1 over sine theta d theta. Okay, and then simplify. So sine squared theta. So I can take out 1 over 2 outside, right? And then I have 1 over sine square theta d theta. It looks like our sine theta here can be cancelled out. Okay, so now I know why they asked us to use the polar, because in terms of integrand, so we have, then later on we have a very simple expression. Okay, so sine squared over sine squared, it is gone. So 1 d theta. So 1 over 2 theta. So pi over 4 to pi over 2. So 1 over 2 pi over 2 minus pi over 4. So 1 over 2 pi over 4, isn't it? We have to multiply by 2, multiply by 2, 2 pi minus pi will give you pi, and we have pi over 8. If they ask you to leave your answer in 4 decimal places, then you have to evaluate. So you have 0.3927. Okay. Or you can leave your answer in this form. Pi, okay, but not the trigonometric function. If there is a sine or tangent, then you have to evaluate. Okay, but it is pi, it doesn't matter. Okay, so what I want to say here, even though sometimes even though your region is not part of the circle, there is a need for you to transform into polar because of maybe in terms of the integrand given, then after you apply the polar, so it can after that transform into a simpler form, then easy for you to integrate. Okay, because you can see here, if you just use the rectangular region or Cartesian, sorry, not rectangular region, but Cartesian coordinate system, then I'm sure that we will get, we need to provide extra steps in integrating this particular function. Okay.